So here we're going to continue correcting the exercises. So we're going to correct this one, the 10th one. So identify the correct products for each chemical equation. Identify the reaction type for each equation. Okay, so we have an equation. For example, I'm going to start with the first one. We have AgNO3 plus, I'm going to write it here. It will be, we have AgNO3 plus BaCl2. We have these two compounds. They will react. We want to know what will they give us. So how I'm going to do it? It is very easy. First, I'm going to take each compound alone, this one and this one, and I'm going to write them here. I have AgNO3. So AgNO3, and I have BaCl2. When they will decompose, this one here, it will give me Ag and NO3. I'm going to put them one, give me Ag and NO3. I'm going to put them here. NO3. But you know what is NO3 and Ag. What is Ag? I have to find the balances. So what are the charges? Because Ag, it is a metal. NO3, it is polyatomic. Recall that I told you, you have to memorize these ones here. It is very important. You see, each time we come back to them. We have NO3. NO3, it is minus. So I'm going to put it here. NO3, it is minus. And what about Ag? Ag, since this one it is minus, this one must be plus. Why? Because they have to cancel. Because plus minus, it gives me 0. Minus 1, plus 1 if you want. It is. I'm going to look at these ones here now. When these ones will dissolve, I'm going to have Ba and Cl2. Not Cl2, I'm going to this one here, Cl. When they are dissolving. But how many Cls I have here? I have 2 Cls, and I have 1 here. So what are the charges? So we go again to my periodic table. What is Ba? The barium. It is here. It is in the column 2. You remember we said that the column 1 we have the charge plus 1. This one it is plus 2. This one it is plus 3, and we have to stop. And here it is 0. This one it is minus 1, minus 2, minus 2, minus 3, minus 4. And you can take them from here also. And the barium here, because you have the table, barium, what is the charge? It is 2. So you can use it as the ones that I showed you, or you can use only the ones that they gave you. It is plus 2 because it is a metal. So I'm going to put it here. It is plus 2. What is about chlorine? Chlorine, it is minus 1. Yeah, again, you can go to your periodic table. The chlorine, it is here. And says chlorine, it is non-metal. So I have to take the negative, because when the non-metal meets a metal, the metal will become positive and the non-metal will become negative. So this is what I have. So now what are going to happen? So I'm going to put them here. I have Ag plus with NO3 minus, and what I have Ba plus, Ba2 plus. We don't have here. What will happen here? We will happen some switching. This one here will go with this negative. This positive now will go with this negative, and this negative will go with this positive. This is the product that I will get. You understand what we are doing? First step, what we did, we have to dissolve each element to the ions that will give me. This one gives me Ag plus, 1 plus, NO3, 1 minus. This one will give me Ba2 plus, and this one. And what's going to happen now? There are some switching. This positive here, before he was with this negative, but now he will go with this negative here. And this negative will go with this positive. It is partner changing. So what I will have here, I'm going to put it in another color. I will have second step here now. This is the product. I will have the Ag 1 plus with what? With Cl minus. And I will have Ba2 plus with NO3 1 minus. These two here will form a compound, and these two here will form the compound. So now what compound will form here? I see here that they are already plus 1 cancel minus 1, because plus 1 plus minus 1 equals 0. So this one I have nothing to do. So I'm going to put AgCl. This one. So I will have, you see, here AgCl. What about these two here? First, this one I have to put it in brackets. Why? Because it is polyatomic. So I have to put it in brackets. And I will put the minus 1 outside the bracket. Always it is one. For the polyatomics, put the polyatomic on bracket and the charge outside the bracket. So here I have to cancel the charges. I have two charges here, but I have only minus 1 here. I'm going to balance it. I have to multiply this one by 2. So I have to put a 2 here. Why? Because here 2 times minus 1, it gives me minus 2. And this one, now it is balancing. Times minus 2 and times 2. Why? Because I put times 2 here and I have to put it in. This is now the charges are balanced because I have minus 2 here and plus 2. Plus 2 minus 2, it is 0. So this ones balance each other, they will go, and we will be left with BaNO3 2. So this is what I will have here. So now I'm going to erase everything here. So you can play again the video to see what I did. Plus BaNO3 2. You see the molecule, you have to cancel the charges. Always you have to cancel the charges. So this is your answer. And here what we have to write, we have to write here that it is AgCl plus BaNO3 2. And what type of reactions? What type of reactions you have? You have these types here. I'm going to state them. Type of reactions. Put them in your notebooklet. Type of reactions. 1. Single displacement. 2. Double displacement. 3. Synthesis. 4. Decomposition. This is the 4 type of reactions that you have to choose from. Here, what reactions we have? It is double displacement, because recall, we had Ag and Cl. This one it was plus, this one minus, and we had Ba plus, and we have NO, and we had no. Step back. We had Ag NO3 minus, it was plus, and we had Ba2 plus, Cl minus. And what we did this one will go with this one, so this is one displacement, and we did this one will go with this one. This is the second displacement. So this ones will go with this one, so first displacement, this one will bound with this one, and this one will bound this one. So this one, it is double displacement. So I'm going to write it down. What type of reaction? Double displacement. Good. So I'm going to do now the next. I'm going to write it double displacement. Double displace. I'm not going to write everything. So let's go to the other one. I have lithium 3N. Again, lithium is a metal. Lithium, what is lithium? It is here. It is a metal. What is nitrogen? It is here. Non-metal. See? So what will happen here now? Note this one. Am I here? Lithium. So I'm going to have lithium, and I have nitrogen. That's it. So what will form? So lithium will stay alone, but nitrogen will be 2. So here it will give me lithium plus nitrogen, because this is what's happening. I have to balance. I will balance them in the end, because they are saying identify correct products for each identified reaction. We don't have to balance them. Okay. Yeah, we don't have to balance them. And but nitrogen doesn't exist alone. If you write it like this one here, it is incorrect. Why? Because nitrogen doesn't exist alone. It is always N2. I'm going to give you the one that always must be with 2. We call them Hankel fibrate. H Hankel fibrate. Like this one. H hydrogen, it must be H2. If you see hydrogen, never you can have hydrogen alone. It's not like lithium. Lithium, I can have lithium alone. Carbon also, I can have carbon also. Nitrogen, I can have nitrogen. Sodium, I can have sodium alone. But hydrogen, always with 2. Oxygen, always 2. Nitrogen, always 2. Chlorine, always 2. Fluorine, always 2. Iodine, always 2. Bromine, always 2. Br2. Acetate, always 82. So this ones you have to record to memorize them. At least you have to memorize this ones here until this ones, because you have to know H doesn't exist alone, always H2, O always O2, like this one you see here, O2. We don't have O alone, O2. So this is the reaction. So what this one here, what type of this reaction here? What type of reaction here? It is decomposition. Why? Because I have one compound and it broke down. I had decomposition because I have lithium 3N. It was one compound. It broke down on 2 pieces, lithium and nitrogen. So what is it? Decomposition. So go right here. Decomposition. Decomposition. Because it breaks down. Okay, I'm going to do the third one. What I have here, I have Zn plus PbCl2. So Zn, it stays Zn, there is nothing here, it is zinc. But PbCl2, yeah, this one it will break down. So it will be give me what? This one it will dissolve because it is compound. It will give me Pb and Cl. How many Cls? It will give me Cl2. 2 Cls here. So what I'm going to do now, we are going to find the valence. I'm going to chlorine. Chlorine it is -1. I know that chlorine it is -1, so I'm going to put it here. -1. This chlorine also it is -1. So to balance, this one must have what? +2. Why? Because I have -1, -1, -2 to balance, it must be +2. So once now I find the charges, yeah, I don't have to keep two chlorines. This one's here. I'm going to have only one chlorine. But this Zn here, what is its charge? I have to find the charge of Zn. The charge of Zn, so we're going to let it like this. Once I have the Zn. So what will happen now? Between these two here, this one will go with this one here. And this one will be left alone. This is the reaction. This Zn, it is more powerful than this Pb. You will kick off the Pb here and he will take the Cl-. So what we'll have Pb alone and Zn will bound with Cl-. What is the charge of Zn? Now I'm going to go to the periodic table. Zn, it is here. What is the charge of Zn? It is 2. So it is +2. So this one here, it will be +2. And these two here, they have to form. So we have to balance the charges. I have only one minus here. So -1 here. But this one is +2. So I have to multiply here by 2. And since I multiply it up by 2, I have to multiply the bottom by 2. So I have a 2 here. So these charges will cancel. And I will end up with what? ZnCl2. So what will I have? What I will have here? I will have here Pb plus ZnCl2. What kind of reaction is this one? There is only one displacement because Zn will pick up the chlorine and Pb, it is alone, he will not have a partner. So it's what? Single displacement because only one changing place. It is Zn, the chlorine that goes with Zn, and the Pb will stay. There is nobody who will pick up the Pb. So it is single displacement. Single displacement. Okay, good. And we are going to do the last one. The last one. So I'm going to, okay, you understand, single displacement now. No. Single displacement. And here I have Rb plus O2. What will give us this ones here? So I have Rb here. You say Rb. Oxygen will be oxygen. I have two oxygens, but I have only one. And I have to take the sodium bound, and I have to go and find the charges. Rb, it is rubium, and rubium, it is metal. So what is the charge of the rubium? 1. The rubium, it is here, and its charge, it is 1. So the charge of rubium, it will be plus 1. What is the charge of oxygen? I go to periodic table again. The oxygen, what is the oxygen? It is here. What is the charge of the oxygen? Minus 2. So I have to put here minus 2. And I have to cancel again the charges. So this one, it is 2 plus minus 2. This one, it's only 1. So I have to have a 2 here. So I multiply by 2 up, and they put a 2 down. So plus 1 times 2, it will be plus 2, minus 2. The charges will cancel, they will go, and I will end up with Rb2O. So this one, it will be Rb2O. So what kind of reaction this one's here? I had two parts, 2 particles, and he gave me 1. You see here, I have 2 particles, 2 molecules. In the end, I ended with 1. There is I didn't see any displacement. There is 1 displacement. So it is why it is synthesis. Synthesis, it is what? When you have 2 pieces or 2 molecules or more than 2 molecules to give you only 1. So this kind of reaction, it is synthesis. Synthesis. And this is the kind of reaction for this exercise. So I hope that you understand it. The way you have to do other exercises, do the key questions, the support questions again until you understand. Okay, good. Maybe. Bye.